Hey everyone, this lecture is going to be about extinction. And over the history of the Earth, the number of families that have been found on Earth has fluctuated quite a bit. So you can see it goes up and down a little bit. But there are certain points in history when there was a drastic drop in global diversity over a relatively short period of time. So those are these dips that you're seeing here. And we call those times the mass extinctions. There are 5 known historical mass extinctions, and the first mass extinction was the Ordovician and Silurian extinction, and it happened about 445 million years ago. And scientists theorize that there were 2 main phases to this extinction. So they think there was a glaciation event and a heating event. And abundant plant life removed carbon dioxide from the air, causing cooling, and glaciers formed. And all of that led to a drop in the sea level, reducing habitat. And then later came natural global warming. The sea level rose again, and the creatures that had adapted to the cooler climates were unable to survive in the increased temperatures. And since most of the fauna was marine life at the time, we actually lost about 70% of the life on the planet. The next mass extinction was the late Devonian extinction, and that was about 365 million years ago. And at that time, about 75% of life died off. And one theory suggests that land plants developed deep roots, which released an abundance of nutrients into the oceans, and that fed the algae in the oceans. And because of this, algae blooms consumed vast amounts of oxygen in the oceans, and that suffocated many of the species. Another theory suggests that another global cooling event might have taken place, resulting in glaciation and a fallen sea level, leading to habitat loss again. Then there was our third mass extinction, which was the Permian-Triassic extinction. It was about 252 million years ago. And this was the deadliest extinction in all of history. So even though most people know about the Triassic or the KT extinction, which we'll get to in a minute, this one was the one that was the most deadly. This one killed about 95% of all life on the planet. And scientists believe that volcanic activity in Siberia put massive amounts of carbon dioxide into the air. And carbon dioxide, as you know, is a greenhouse gas. And bacteria that thrive on CO2 began producing more and more methane, which is another greenhouse gas, and is actually even more potent than CO2 is for this. So large quantities of both of those gases warmed up the whole planet, and they combined with the Earth's water, and it made the ocean acidic, which in turn made the rain acidic. And all of it just created a really highly toxic environment for life. So you're going to see in a minute how these extinction events and what is happening today on Earth kind of go hand in hand. So the fourth mass extinction was the Triassic-Jurassic mass extinction, and that was about 200 million years ago. Some scientists theorize that volcanic eruptions spewed tons of CO2 into the atmosphere, and that trapped heat and acidified the oceans again, and that caused a mass extinction. But other scientists think maybe it was another asteroid or comet that had impacted the Earth and caused an extinction. But for that extinction event, about 80% of life was lost. That was including most of the mammals, and what that did is it made way for the dinosaurs to come in. So when you watch things like Jurassic Park, most of those dinosaurs in there were not around even close to the same times. Some of them lived during the Triassic period, some of them lived during the Cretaceous period, so they were separated by millions of years, so not super realistic. Then we had the fifth mass extinction, and that's the one that everyone knows about. That's the extinction that wiped out all of the dinosaurs. It was the Cretaceous-Paleogene extinction, or the KT extinction, and it's about 66 million years ago. And that one wiped about 75% of all life off of Earth. And a widely accepted theory is that an asteroid landed in the Yucatan Peninsula in Mexico and killed all of the dinosaurs. So the impact would have ejected enormous amounts of debris into the atmosphere. It would have caused the global temperatures to drop, and it could have caused local fires, earthquakes, tsunamis, acid rain. So really just would have made the entire Earth uninhabitable, sorry. So those are the 5 historical mass extinctions. But there's also a lot of speculation that we're in our own mass extinction right now. And even though some of the other mass extinctions have debatable origins, there's really no question as to what's causing the 6th mass extinction. Humans are the cause. The current extinction rate is at least 1,000 times greater than the normal or background extinction rate. And the background extinction rate is supposed to be the average rate of extinction based on the longevity of species throughout time without human interference. And we can determine a lot of that by the fossil record. Scientists believe that the human impact on the environment is the leading cause of extinctions today. So they've actually named the era that we're in, and we call it the Anthropocene, so the age of humans. And it's really us right now that are causing the majority of the extinctions on our planet. Of course, this background extinction is still happening. So there are some species that we haven't, we don't necessarily have an impact on, and why they go extinct. But for the most part, it's us. And it's even more upsetting when you think about the fact that we're the ones doing this, because when you look at the history of the Earth and you scale it down and you have a 24-hour clock, humans haven't been around for that long. So we turn the entire history into this 24 hours. The dinosaurs would have appeared around 10:47 p.m. So that's pretty late in the night, right? A ton happened before that. The Earth has been around for a really long time. And mammals only appeared at 10:56 p.m. And then humans, we showed up at 11:59 and 12 seconds. So we haven't even been here for a minute of the time that Earth has been around. We've been here for such an insignificant amount of time, yet we've had a massive impact on our environment. So when you compare the global increase of the human population, you can really see a direct correlation with our increase and the increase of extinctions. So and it really increased a lot fairly recently, pretty much around 1900. It started going up quite a bit, and we'll get into some reasons why in a second. And unfortunately, things are getting a lot worse. When we look at the time period from 1500 to 1900, there were humans around, right? We were still here. It's not like we're that new. But for that whole 400 years, only 140 species went extinct. Now, in the last 120 years, just since 1900, we've had 477 species go extinct. And this is actually from 2015, so it's gone up even more since that. This is about 5 years old, these numbers. So we've caused quite an increase in the extinction rate in just the last 120 years. And it's in every group of animal. So this right here shows the increase in extinction since European settlement. So this is where European settlement happened, and around the time when the Industrial Revolution began in about 1760 is where you start seeing an even larger increase. So the extinction rate just shot up after the Industrial Revolution. An ecologist named David Wilkove defined the 4 horsemen of extinction. So these are the 4 biggest causes of extinction. And soon after, he realized that there's really a 5th one. So he had his 4 original horsemen were habitat destruction, alien species, overexploitation, and disease. And later he added pollution. So all of these things are major causes for extinction. And I want you to take a second and guess what you think the number 1 cause might be. They're all definitely important. They are all definitely causes of extinction, but take a second and try to think of what the number 1 cause is. So the number 1 cause for extinction for all groups is habitat destruction. And that affects 85% of imperiled species. Alien species or introduced or invasive species, they're the number 2 threat, and they affect about 49% of imperiled species. But they're actually most important for plants and on islands like Hawaii, because they're really in a smaller ecosystem, and any introduced species really has a larger impact. Then you have overexploitation. That's of particular importance for things like reptiles, mammals, and birds, things that are taken for food or for the wildlife trade or for the trade in medicine. There's a ton of different reasons why they are overexploited. Then you have disease, which actually affects birds more than other groups, but it's become a recent issue with amphibians. And we're going to talk about an amphibian disease a little bit today, and then a little bit more when we talk about diseases in general. And then finally, we have pollution, which is actually the number 2 threat for aquatic species. So it's of particular importance for fishes and mussels. So we're going to talk a little bit about each of these things throughout the class. Next week, we're really going to focus on all of these things and go into more detail. But for today, we're going to focus on how these things lead to extinction and some of the examples of extinction that we've seen recently. So there are some characteristics that predispose species to extinction. We have natural rarity, which we'll get into in quite a bit of detail in a second. Then there's limited adaptability. So low reproductive capacities are an example. So if you think of something like an elephant, which has 1 or 2 offspring every few years, they have a low reproductive capacity. When you compare that to something like an insect who will lay 500 eggs every year, there's quite a bit of a difference there. Then there's limited dispersal abilities. So this is especially important in species that have a small habitat ranges. So in turtles, in freshwater fish, in anything that amphibians really. There's quite a few things that have limited abilities to disperse to new areas. Then there's habitat specialists, so individuals that need specific habitats. So an example of that would be like a siren. They have a very specific habitat which they need to be in. They're in very shallow fresh water, and they're not found in very many places. Then we have special behavioral tendencies. And an example of that would be something like whales or hibernating bats. So you have to think hibernating bats, right? They have a behavioral tendency. They need to have somewhere to hibernate. They need to have some sort of place to overwinter. So because they have that tendency, they become more at risk. They need that extra thing. Another thing that predisposes a species to extinction is large geographic ranges. So, for example, large carnivores that migrate a long way have a large individual geographic range. And that's been affected by fragmentation. So in the genetics lecture, I mentioned that cheetahs are having issues because they have such a large range. and now all of their range has become patchy because we have built up areas, and it takes longer for them to get from one patch where they can hunt to another patch where they can hunt. And they're actually starving before they're able to find more food. Then we have migratory species. So these species are at risk because they require a winter and a summer area. So we need to have two habitats available for them. Also, migration is risky itself. Migration has a very high mortality rate. So they take this big risk by going somewhere different for the summer and the winter. And then also species that have particular human attention. So ones that we find that we want for something, really. So when I said rarity, there's actually quite a bit that goes into determining how a species is rare. Now, rarity is really the best predictor of extinction. That's why when you go to the IUCN Red List, a lot of it has to do with the population size, how easily they're found. All of these things, rarity really comes into it the most. One classic analysis of rarity was done by a woman named Deborah Rabinowitz, and she looked at rarity in the British flora. And she determined that there's really three aspects to whether a species is rare. You have the population size, you have their geographic range, and you have their habitat specialization. And there's extremes in each of these categories. So what she did is she came up with this system that came up with 7 types of rarity. So you have 7 types of rarity here, and then one combination of habitat specificity, population sizes, and geographic distribution that is not considered rare. So the one that would not be rare would be if they have a wide geographic distribution, a broad habitat specificity, and a large population size. So that would not be a rare individual. However, you can have any combination of these categories. So you can have, there are 7 different rare categories. And when she looked at the flora in Britain, she found that 36% of the species that she looked at were common in all the dimensions, which means they were in this category here on the left. 2% were rare in all dimensions, so that would be the rarest category. And 62% were rare in 1 or 2 dimensions, so that's the other 6 rarity categories. So there's just some examples here of species that can be found in each of these categories. There's a ton of examples for each of them. Really, the more categories that you're rare in, the more likely you are to be at risk for extinction. So there's a species called the Kirtland's warbler, and it's rare in all dimensions. There's only a few thousand in existence. They breed only in a few counties in southern Michigan, and they're found at really small population densities. They'll only breed in jack pine stands, and they'll only breed if the jack pines are of a certain age. So they're very particular. They're very specific about where they'll live. And so you can imagine this species has a much higher risk than many other species. So they have a higher risk than if a species was only rare in 1 or 2 of the categories. And a study on bighorn sheep populations that were living on a semi-isolated mountain range demonstrated that the larger populations were actually likely to persist longer than the small populations. And all of the populations that had less than 50 individuals went extinct within 50 years. So they put these into categories, and they had populations that had 15 individuals or less, 16 to 30 individuals, 31 to 50, 51 to 100, or 101 or more. And all of these that had less than 50 went extinct by 50 years. The one with 51 to 100 individuals went extinct after 60 years. The only one that persisted are the ones that had over 100 individuals. So population size really comes into play when we're talking about what makes a species more likely to go extinct. And that's why that's part of determining whether a species is rare. Similarly, a study on the risk of extinction for populations of 62 bird species off the coast of Britain and Ireland, it found that in general, species with smaller populations were at greater risk. And you might notice that it counts the number of nesting pairs here, not the size of the actual population. So that brings us back to our genetics lecture and when we talked about effective population size. And in scenarios like this, we're not counting every individual that exists because not every individual is going to be contributing to the next generation. So here they're just counting the effective population size, which is the number of breeding adults. So to estimate the likelihood of extinction, we can perform a population viability analysis. And what this does is it uses data on things like the reproductive rate, the population size, and survival to predict if a species is going to persist and for how long it's going to persist. So conservationists can use programs like Ramus Ecolab, like you guys are using, and they can incorporate things like stochasticity or natural variation and make repeated runs. So they'll run the program over and over again with natural variation going. And what they'll get is they'll get something that looks like this. Each line on this graph represents one of the runs that they did. So these are the ways that the population could really naturally vary within the with each run. So if you do enough runs, you can actually calculate the probability of extinction under the parameters that you put in. And we can express this in multiple ways. So you can figure out the probability of a population persisting for several years. You can find out the probability of a population going extinct in however many years. You can determine what the minimum viable population is. So you can change the initial population to figure out how many you need to have in order for this population to persist. And typically 50 to 500 is the minimum that a population should be. And it really should be much higher. Whenever populations get near this small, it's usually a lost cause. Kind of how you saw with the bighorn sheep where anything under 100 didn't stay alive. And then there's they can also find out the contributing factors to extinction. So depending on what features you toggle on or off in your analysis, you can change the initial population size, the randomness or stochasticity. You can change the amount of drift, the genetic drift that's happening. So you can change all these things and you can figure out what is really going to be the highest contributing factor to extinction of the species you're looking at. So by putting in information about the species that you already know, you can model what could happen and get an idea of how the future is going to look for this species. So even though we're using Ramus Ecolab for predetermined labs, programs like that are used all the time in conservation biology. They're used for modeling a lot. You might notice that your labs this week have a button called demographic stochasticity, and I asked you guys to toggle that off when you're taking the labs. And what that is stochasticity is the randomness that occurs in the environment. So it occurs all the time in nature, but it's important to be able to account for these things when we're modeling how future populations could change. So demographic stochasticity is the randomness in a basic population and their characteristics. So what it does is it randomizes the birth and death rates. It just fluctuates them a little bit the way that it would in a natural environment. And then it fluctuates the sex ratio. So it could go from it could go from 95 females and 5 males, or it could go to 90 females and 10 males. It's not going to do it like an extreme. It's not going to switch them like that, but it will naturally vary them. Um, and then you have environmental or random, which is random variations in the environment. So what that is it's going to take into account things like precipitation, temperature, freezes. It's going to add all of these natural random variations that you can have that can cause fluctuations in populations. There's also catastrophe stochasticity, which adds discrete extreme events. So these are events that have their own individual independent probabilities. So it can be things like an earthquake, or a tornado comes by, or it could even be events like a disease comes and wipes out half the population. So these are large events. And then you have genetic stochasticity, which adds drift and the probability of losing alleles from drift. So there's all different things that conservationists can do when they are modeling a population and how it's going to persist. They can really look at all of the possible things that could happen in nature and get a general idea of what should happen if these things happen. So we can document at least 1,000 named species that have gone extinct. And this problem that all these species were going extinct led E.O. Wilson to come up with the species area relationship to estimate how many species have gone extinct based on the amount of habitat that's been lost. So it's estimated that we're losing around 1.8% of habitat every year. And with the species area relationship, you can estimate that there were about 27,000 species that have gone extinct every year. So if you compare that with the background extinction rate, and you assume that all species have a lifespan of around 1,000,000 years before they go extinct or become a new species, and you assume there's about 10 million species in total, we would expect that about 10 species would go extinct every year due to background extinction, so extinction without our influence. But if we're seeing 27,000 species go extinct per year, that's 2,700 times the background rate. So that's a way higher level of extinction than we ever expected. So we've lost more species than we can count. But I do want to go through some of the species that were kind of turning points for the conservation world, and ones that really marked big extinctions in our history. So these are all going to be things that have gone extinct in the last couple hundred years at most. A lot of them were very recent, but we're going to talk about a few of them. So first we have the dodo. Pretty much everyone has heard of a dodo. It's kind of like a very well-known extinct bird, but a lot of people don't really realize how recently it went extinct. So this was one of the first widely known species that humans are credited with driving to extinction. And the dodo was a flightless bird. It was native to an island called Mauritius. And it's believed that the dodo went extinct because Dutch sailors hunted them and ate them to extinction, starting in around 1598. So they were flightless. They had no fear of humans, and that made them really easy prey to catch. They also faced decline due to introduced species like dogs, pigs, and rats that were all brought to the island with the settlers. So they were often killed by these animals. They would eat their eggs, and it ended up going extinct less than 80 years after humans colonized that island. So it did not take very long for this bird to go extinct. And I have a fun fact for you, kind of. There used to be a species of parrot that was native to the United States. The Carolina parakeet ranged from southern New England down to Florida and all the way west to Colorado. But unfortunately, the last Carolina parakeet died in the Cincinnati Zoo in 1918. And they were very abundant but farmers kind of saw them as pests because they would eat some of the crops. So they would kill whole flocks at a time. And unfortunately, the parakeets made it easier for the farmers to capture them and to kill them because after one died, they would gather around their dead flock member. So it was really sad. They would gather around and then they would be killed. So they were also killed for their beautiful feathers. You can see they've got some beautiful plumage. And their feathers became popular hat accessories in the 20th century. So people were killing them in order to use their feathers to decorate their hats. And of course, habitat loss was a major factor in their decline. A ton of their land was removed for agriculture, which would explain why they were now feeding on crops because they used to live there and now there's crops there to eat. And many of their nesting sites were also torn down to make room for agriculture. We actually have a sample of Carolina parakeet DNA, and researchers were able to examine their DNA and see that what the genetic diversity in the species was like. So they found the Carolina parakeet was actually more genetically diverse than any other birds that were alive today. And that suggested that their extinction process was actually really abrupt. They had no time to leave lasting marks on their genome. If it had happened more slowly, then you would have expected there would have been many small populations, there would have been more inbreeding, and genetic diversity would have decreased. Dude, hold on. Hey. Stop. Okay, sorry. That's going to happen a lot. So they went extinct very fast. Then we have the world's largest marsupial carnivore. So it's a marsupial, like I said, so it's related to like kangaroos and koalas. And this was the thylacine, and it was also commonly known as the Tasmanian tiger, and that was due to its stripes that were on the back. So a number of factors, including the introduction of the dingo, led to the extinction of the thylacine in all of its areas except for in Tasmania. And that was about 2,000 years ago. The thylacine population in Tasmania at the time of European settlement in the early 1800s was estimated to be around 5,000 individuals. So when settlers arrived, they cleared large areas of land and they cultivated livestock like sheep and cattle. And even though there was evidence that feral dogs and widespread mismanagement were responsible for the majority of their livestock that got killed or went missing, the thylacine kind of became the easy scapegoat. So all of the farmers really hated the thylacine because they believed it was coming in and killing their livestock, even though there really wasn't much evidence to that. And as early as 1830, they set up bounty systems for the thylacine. And farm owners were pooling money to pay for skins. So the government in 1888 also introduced a bounty on thylacines. They would pay you £1 per full-grown animal and 10 shillings per juvenile. So if you went out and killed them and you brought them in, they gave you some money. And that program lasted until around 1909. And it actually awarded more than 2,100 bounties. So they killed quite a few thylacines. And with a population of only 5,000, that's quite a bit. And that was only under that program. Those are only the ones that died under the program. It's estimated that at least 3,500 thylacines were killed by human hunting between 1830 and 1920. And another issue for them was the introduction of competitive species like wild dogs and foreign diseases, including mange. They also lost a ton of their habitat. And all of these things really contributed to their loss, and it was just kind of piling on for them. And the last known shooting of a wild thylacine took place in 1930. And by the mid part of that decade, sightings in the wild were very rare. So they rarely ever saw them, and they were still being hunted. authorities from the scientific and zoological communities became concerned about the population, so they pushed for preservation measures to be undertaken. However, the public didn't really want that at first. And by the time the public changed their mind and conservation action came, it was too late for them. So the species was granted protection, it was granted protected status, and then 59 days later, the last individual died. And that was a captive individual named Benjamin. This is Benjamin. He was the last known thylacine, and he died in the Hobart Zoo. Unfortunately, he died from suspected neglect, so they weren't taking very good care of him, and that was in 1936. That was the last individual ever. Then we have the golden toad. And this was another turning point for conservation. The extinction of the golden toad was a kind of big moment in the amphibian conservation world. So at the top we have a photo of a female, and the bottom is a male. You can see they're very beautiful toads. And they were only discovered around in 1964. And unfortunately, the last individual was seen in 1989. So they were only around for like 25 years that we knew of them. Obviously they were around before 1964, but we only knew of them for a very short period of time. So they were once really abundant in a cloud forest in the North Monteverde in Costa Rica. So what that is it's a tropical montane forest, and it has frequent cloud cover. So the forest is covered in clouds. It's very damp in the forest. And in 1987, between April and July, researchers found nearly 1,500 adult toads scattered between a few little shallow ponds that were in the forest. And it was really a sight to be seen because it's such a small little area, and there's 1,500 of these beautiful, vibrant, bright toads all breeding and converging in puddles. And then after they're done breeding, they actually go underground. So you only really see them for their breeding time every year. So that was in 1987. But then in 1988, scientists found only one toad in that area. And then they documented about 9 more a few miles away. And then the next year, in 1989, they had one male and nothing else. And that was the last time they ever saw one. So finally, in 2004, the IUCN list declared them extinct. So they went from 1,500 individuals to 10 in just 1 year. And then the next year they went from 10 to 1, and then they were gone. So it was very, very quick. They dropped 99% in a year. So it's believed that their decline was due to climate change. The forest became unusually dry, and it's thought that this change made them more susceptible to a fungal disease called chytrid. And we're going to talk a bunch about chytrid later in the course when we get to disease. So this species is actually considered the first documented species to have ever gone extinct as an impact of climate change. Although there is some debate and controversy over giving them that title. Some people don't like that title. So another species that went extinct very recently is the rarest of the black rhino subspecies. So this is the western black rhino. It was recognized by the IUCN as extinct in 2011, so very recently. And this species was once widespread in Central Africa, but the population began to decline really steeply due to poaching. And it was listed as critically endangered in 2008. But a survey of their last remaining habitat in northern Cameroon failed to find any indications of its presence. So it was probably already extinct at that point. There are no known individuals in captivity, unfortunately. And even though this is just a subspecies of black rhino, all rhinos are really in trouble right now. However, some things are looking up for the eastern black rhino. They had 2 babies that were born in captivity and released into the wild in 2012, and that brought their population up to 702 individuals. So there's still hope for the other species. Unfortunately, the western did not make it, though. Then we have a species that almost nobody's heard of. And there is a reason why this one is in the list. The reason this is included, this is the Bramble K malomus, sorry. The reason he's included is because this is the first documented mammal extinction due to human climate change. So it was declared extinct in May of 2015. It's an Australian species, and the last sighting was in 2009. So really it went extinct due to partially loss of habitat, and a loss of the island's vegetation that it was on. And it really went extinct though due to rising sea levels. So scientists found that the rising sea levels caused storms to flood the island more readily, and many of the animals died. So it's credited with being the first mammal extinction due to human climate change. Then we have the Pyrenean ibex. It's one of 2 extinct subspecies in the Spanish ibex group, and it was declared extinct in 2000. So this species, it roamed all over France and Spain. It was very numerous. By the early 1900s, its numbers had fallen to less than 100 individuals. So the last Pyrenean ibex, a female named Celia, she was found dead in Spain on January 6th, 2000. And it was determined, this one wasn't our fault, it was determined that she had been killed by a falling tree. So it was just a random event, very sad. But everything before that was because of us. But scientists did take skin cells from her ear, and they were able to preserve them in liquid nitrogen. And in 2003, they actually cloned this ibex, and it made it the first species ever to become unextinct. Unfortunately, the clone only survived 7 minutes. But they haven't stopped trying. Cloning is a very controversial subject when it comes to bringing animals back. A lot of scientists have been trying to de-extinct some animals and bring them back via cloning. So we do have DNA samples of a lot of different types of animals that have gone extinct, especially the ones that have gone extinct more recently. Unfortunately, this species, they went extinct, most likely they say is due to poaching, disease, and the inability to compete with other species for food. Then we have this crazy example. This is like the craziest frog in the world to me. We have the southern gastric brooding frog. It was an aquatic frog. It lived in Southeast Australia. And in 2002, the IUCN declared them extinct. Even though we actually haven't seen any wild individuals since 1981, and all of the captive individuals died by 1983. It did take that long, though, to be sure that there were none left in the wild, and they finally declared it extinct. So this was a really interesting species. Females would lay eggs, then she would ingest them, and the eggs would develop inside her stomach for 6 to 7 weeks while they incubated. And then 6 to 7 weeks later, 20 to 25 little juvenile frogs would come hopping out of her mouth. And the mother would be fine. This wouldn't kill her. The entire time while the juveniles were developing, the mother fasted and she was pretty much inactive. And the stomach was really functioning as a uterus. the musculature and blood vessels were altered when the froglets were in there developing. There was also a decrease in stomach secreting acids. Um, but again, just like the golden toad, it's thought that they died off due to climate change, drought, and chytrid fungus. Um, and they were discovered in 1973, and by 1983, it was listed as vulnerable, even though it was already probably extinct. So that's just crazy to me that a species could be extinct for a couple years and still only get listed as vulnerable. So it takes quite a bit of time and effort in order to really list a species. Then we have an example that a lot of people might have heard of. So this is the Pinta Island giant tortoise. The last known individual was named Lonesome George. He was an icon of the Galapagos. He died in captivity in 2012, and he was thought to be over 100 years old, which actually wasn't super old for them. They can live up to 200 years old. They were actually among the species that helped Charles Darwin formulate his theory on evolution in the 19th century. But unfortunately, they were hunted for their meat by sailors and fishermen, and they were pretty much hunted to the point of extinction. And to add to this, a lot of their habitat has been eaten away by goats that have been introduced to the island. So an introduced species and decrease in habitat. So here's one final extinct individual. This one to me is probably the most appalling and heartbreaking extinction that we have ever caused. This is the passenger pigeon. In May 1850, a tribal leader named Simon Pogokin was camping at the headwaters in Michigan's Manistee River, and he heard a really far off gurgling type sound, and it startled him. And he said it seemed as if an army of horses laden with sleigh bells was advancing through the deep forest towards me. And as I listened more intently, I concluded that instead of a trampling horse, it was a distant thunder. And yet the morning was clear, calm, and beautiful. The mysterious sound came nearer and nearer until he decided that what it was is, he says, while I gazed in wonder and astonishment, I beheld moving towards me an unbroken front of millions of pigeons, the first I had seen of that season. So these were passenger pigeons, right? And at the time, this was the most abundant bird in North America, and possibly even the world. It was very abundant. Throughout the 19th century, witnesses had described similar events of sighting these pigeons in their migration, and how they took hours to pass over a single spot, darkening the sky as they passed over. And their wings flapping was so loud that you could barely even hear each other speak over it. So you could just imagine that many individuals. This is millions and millions of individuals. It's insane. You can barely even imagine it. A flock of birds being so large that it takes hours to pass over. So Pocogon, the one that we were just speaking of, remembered how sometimes a traveling flock arriving at like a deep valley would just pour hundreds of feet down into the valley. So he said, I've stood by the grandest waterfall in America, yet never, to my astonishment, wonder, or admiration have been so stirred by what I witnessed with these birds drop from the course like meteors from heaven. So they would just flood down into valleys. There were just so many. I can't overestimate how many birds there were. And observers reported trees crammed with dozens of birds and dozens of nests in one tree. They weighed so much with all the birds in the tree that the branches were snapping off. In 1871, which was right before they started to decline, their communal nesting sites covered over 850 square miles in Wisconsin alone, which is the area where they were often seen. And there were estimated to be over 136 million breeding pairs in just that state. So this was really the most abundant bird. And after that, the population started to plummet. And by the mid 1890s, just 20 years later, the wild flock sizes numbered in the dozens instead of the hundreds of millions or even billions. We don't really know. And then after that, they disappeared altogether, except for 3 captive breeding flocks spread across the Midwest. And around September 1st, 1914, the last known passenger pigeon, a female named Martha, died in the Cincinnati Zoo, and she was about 29 years old. So probably thinking, what causes extinction, right? How could a species go from the most abundant in the world to extinct in less than 50 years? And of course, we're going to keep our theme of the class going, and it was us, obviously. So the passenger pigeon was hunted out of existence. People would hunt them for food. Farmers would kill them for eating their crops. The flocks were so thick that hunting was easy. You could wave a pole through the flock and kill some birds. It was that easy. It was so thick, sometimes they would fly so low. And still, it wasn't the hunting for food that threatened their survival. What happened is after the Civil War, there were 2 technological developments that were set in motion that caused the pigeon's extinction. So the first thing was the expansion of the telegraph throughout the nation and the railroad. So what happened with this is it enabled a commercial pigeon industry to start. And it was fueled by professional sportsmen who could learn quickly about where there were new nestings and follow flocks around the continent using the telegraph. And they could ship their dead birds along the whole continent using the railroad. So this bird probably was treated the worst of any animal that we've ever caused to go extinct. They shot the pigeons, they trapped them with nets. They even went so far as to burn them in their roosts while they were sleeping. They would light them on fire. They would also light barrels of sulfur under the trees where they were roosting so that the birds, while they were sleeping, would asphyxiate, and then they would fall out of the trees dead. They would attack them with rakes and pitchforks. They would throw things at them. They even started poisoning them by soaking corn in whiskey and offering it as food. So all of these terrible things that we were doing just to get rid of a bird for not really sure as to the reason. It's not really a real reason for why we did this. So learning some of these methods, the tribal leader, Simon Pagokin, that we were talking of earlier, said that, where is it? There we go. These outlaws, to all moral sense, would touch a lighted match to the bark of a tree at the base, when with a flash, more like an explosion, the blast would reach every limb of the tree. So he wrote this of an 1880 massacre, describing how the scorched adults would flee and the squabs or baby pigeons would burst open, hitting the ground. Witnessing this, he wondered what type of divine punishment might be awaiting our neighbors who have so wantonly butchered and driven from our forests these wild pigeons, the most beautiful flowers of the animal creation of North America. So it was really it was a heartbreaking moment, and there were so many people that were upset by this, but it wasn't enough. There were so many people that were willing to kill them and sell them for their meat and pretty much and their feathers, and just get rid of them because they saw them as a nuisance. So ultimately, the pigeon's survival strategy, which was flying in huge predator-proof flocks, proved to be their undoing. They might have even survived the commercial slaughter if the hunters weren't also disrupting their nesting grounds and killing adults, driving away others, harvesting the juveniles, taking the eggs. So it was really just a lot of things on top of each other that were just causing this decline. And the last known victim to hunting was a female that they nicknamed Buttons. She was shot in Pike County, Ohio in 1900, and she was mounted by the sheriff's wife. And the reason she was nicknamed Buttons is because they used two buttons for her eyes instead of glass eyes. And then about 70 years later, a man came forward and took responsibility for shooting the last passenger pigeon. He was a young boy at that time, and he didn't even know what it was. He was just going hunting. Another problem was, even as the pigeon numbers crashed, there really weren't any efforts to save them. People kind of just slaughtered them more intensely. So they just kept killing them off until there was nothing left. There was never really that moment of, oh my God, we're losing this species, we need to save them. It never really happened. They just kind of just kept being killed until they were gone. So environmentalism was eventually partly fueled by the extinction of the passenger pigeon. In 1900, when the only surviving passenger pigeon was Martha in the Cincinnati Zoo, which this is Martha here. She's now stuffed, but that was Martha. So in 1900, she was still alive, so they weren't completely extinct, but they were functionally extinct. They weren't able to produce any more individuals. A Republican congressman named John F. Lacey, you might recognize the name there, of Iowa, introduced the nation's first wildlife protection law. So that was the Lacey Act. And it banned the interstate shipping of unlawfully killed game. So we learned about the Lacey Act in our first lecture, right? This is what sparked him. And this is what allowed him to get people's attention. So when he proposed the act, he said that the wild pigeon, formerly in flocks of millions, has entirely disappeared from the face of earth. We have given an awful exhibition of slaughter and destruction, which may serve as a warning to all of mankind, and let us now give an example of wise conservation of what remains of the gifts of nature. So that year, he was able to persuade Congress, and they passed the Lacey Act. And that was actually followed by the Weeks-McLean Act, which we didn't discuss, but what that was, it was in 1913, and what it did is it just set national hunting seasons. So it created hunting seasons nationwide. And then 5 years later, we had the Migratory Bird Treaty Act, which protected not just birds, but also their eggs, their nests, and their feathers. So all of this was really sparked by this massive extinction that we caused. At least we realized afterwards the harm that we had done, and many people are trying to kind of reverse the damage we've done on other species and save them by having these laws in place. So there are other categories of extinct that don't necessarily mean every individual is gone. A species can be extinct in the wild, which means that there's no individuals left in the wild, but captive individuals remain. And some of these individuals actually have captive populations that hopefully one day can be reintroduced into the wild. And then there's the term functionally extinct. And what this means is that there's so few individuals left that there's really no chance for the species to come back. So when Martha the passenger pigeon and Lonesome George were alive, their species was considered functionally extinct. So they still had an individual, but there was nothing you could really do to save the species because you only have one. You can't bring a species back from that. And it doesn't necessarily have to be one individual to make a species functionally extinct. There can be more. A lot of things come into play, so it has to do with how often they can have offspring, whether the live individuals are really going to be able to breed and produce offspring. So other things come into play. So I just have one example of each of these categories. So for extinct in the wild, an example of that would be like the Spix's macaw. and they're endemic to Brazil, which means they're only found in Brazil. And they were last seen in the wild in 2016. It was declared extinct in the wild in 2019, but we do still have around 160 parrots alive in captivity. And this species actually had a nice little moment in the spotlight when the movie Rio came out, and there was a Spix's macaw named Blue in that movie. So that was in 2011. They had a little moment in the spotlight, and they had a little bit more attention paid to them. But unfortunately, there are still only 160 individuals left. They are captively breeding them, and they're hoping one day to reintroduce them into the wild. So what caused their decline in the first place was actually at the mostly the illegal pet trade. So there was also some habitat loss, but the illegal pet trade was really the main thing. And that's a really big factor when it comes to the decline in birds and reptiles. Birds and reptiles really have a very terrible time with the illegal pet trade, and especially birds that are beautiful like these guys. Then we have a species that was considered functionally extinct. So this is the Yangtze giant soft shell turtle. And this is the largest freshwater turtle in the world. The largest individuals can weigh over 500 pounds. And they declined really drastically over the last 100 years. And that's because of overhunting for food, hunting for alternative medicine, pollution, and the damming of the rivers where they live. And in 2019, there were 4 known individuals in the world. They had 1 male and 1 female in captivity, and then they had 2 individuals that lived in the wild, but their sexes were unknown. They had yet to capture them. They just had sightings. And then, unfortunately, in April 2019, the last known female, the one they had in captivity, died. Conservationists had been trying to artificially inseminate her, but their efforts didn't work, and they thought that she was probably sterile. Unfortunately, they couldn't use the male to breed with her because he was mutilated by another captive turtle who is now dead, and he could no longer breed. So at that point, there were 3 individuals left in the world that we knew of. All of them were male, as far as to our knowledge. They were all male, and the only one we had in captivity was unable to mate anyway. So that made the species functionally extinct. But some good news happened. On October 22nd of this past year, so just a couple months ago, they found a female. So they found her in a lake. There was possibly 1 other individual in that lake that they have yet to capture. They don't know what sex the other individual is, but she's been brought to a rescue, the same place where they have this guy right here. This is the male that they have. She's been brought to the rescue, and they're hoping to use her to start bringing back the species. So if they could capture a male, that would also help. But they do have some sperm frozen and ready to artificially inseminate her if need be. And this is one type of species where if they do find a male and a female that are able to breed and produce offspring, it's possible to bring them back. They would have severely decreased genetic diversity, which is going to make some issues, but they do lay anywhere from like 50 to 100 eggs, and they can have that many babies. So it's a little easier to do it with one of these types of species than it would be for a species that has like 1 baby every couple years. So we're hoping that they are able to breed her and have some more individuals. So this may be a success story one day. Right now, all hope was lost until October, but that female really brought some hope back. Okay, so that is it for today's lecture. I have one more lecture that will be uploaded probably tomorrow morning, and that's it. Have a good week.